When adding and subtracting fractions, we need to make sure we have a common denominator. Now, it's important to remember that we do not need a common denominator for multiplication and division, but we need one for adding and subtracting. When you're finding a common denominator, we find this by taking a look at our denominators and looking for factors. So whatever factor is missing from one side, we need to include, and vice versa. So when I look at the 4, I need a times 3 on the bottom because I have a times 3 down here, and I need to balance a fraction with a times 3 on top. Looking at the other fraction here, I'm missing a times 4, so I need to make sure I have a times 4 here and a times 4 here. That makes my common denominator 12. And when I work this out, and make sure that you're showing these times factors, make sure you're showing the fraction with the common denominator. So once I have this, I can then, once the denominator is the same, I have the same size pieces. That's what the denominator represents. The numerator represents the number of pieces. So I can then add the 4 pieces here and the 9 pieces here to get 13 pieces. Now the size of the pieces do not change, so I do not add the denominator. For this one, we do the same thing. We're looking for a multiplying factor to make these the same. So I need a times 5 here, a times 5 here. I need a times by 8 here, and I need a times by 8 here. That gives me 15 over 40 minus 8 over 40. So what that represents then is I have 15 pieces of size 40 fractions. I'm going to take away 8 of those same size pieces. I've got the common denominator, so I can count them the same. So I end up with 7 pieces, and the size of the pieces do not change. So I have a divide of 1/40th fractions. So when we draw pictures of these addition and subtraction, so I'll draw the first one. I have 1/3. Maybe I'll just shade that with, with a highlighter. There's my 1/3 fraction. I'll do the same thing here with the 1/4, or sorry, 3/4. The problem with adding these to the way they are is that we do not have the same size pieces. Okay, those boxes are different sizes. In order to make them the same size, we need to, the 1/3 one, we need to multiply by 4 on top and bottom, so we need to do this in groups of 4. So again, multiplication is in groups. So now there's my 4 in the numerator, and then when I group the denominator in groups of 4, I have now 12 pieces that make up my whole. For the 3/4, I times by 3 times by 3. That means I need to group this in groups of 3. And when I do it in groups of 3, there's my 9/12 here. And then if I do everything in groups of 3, I have the 12 pieces that make up the whole. Now each one of these rectangular pieces now are the same size. Now I can add them together. So when I add them together, I end up with 12 1/12 fractions. So I have 12/12 plus an extra 1/12 fraction. So I have 13/12. Okay, so there's my 13/12 fraction. I can show that with these bars like this. In multiplication and division, we do not need to have a common denominator. The rule that we use for multiplication and division is top times top and bottom times bottom. So when I multiply this, really this is just one fraction because this is divide times and divider are essentially the same. They work the same way. So this is all just one big fraction with times on top, divide on bottom. So I end up with 1 times 3, 2 times 4, and there's my answer. We can draw a picture for this multiplication, and using our grid method, we can see how we get these pieces. So my 1/2, if I do this along my horizontal, there's my 1/2. Okay, so that's 1 out of 2 pieces along the horizontal. Okay, I'm just going to shade, that's the piece I want. On the vertical, I'm going to draw my 3/4. So there's my 3/4. So that's the length I want along the vertical. The whole box represents one whole because I have a 1 by 1 box. The part that I want is going to be this length and width, which gives me this area here. So I can now see that the 1 piece on top and the 3 pieces on top give me the 3 pieces on top as my answer of the area. The 2 pieces that make up the bottom and the 4 pieces that make up the bottom make up my 12 pieces, so my 8 pieces that make up my denominator. So that's why top times top and bottom times bottom. We can see physically that they give us the correct proportions. For division, we want to multiply. But in order to multiply, since multiply is the opposite of divide, I need to do another opposite to balance that opposite. So to do another opposite, we do this by flipping the second fraction. And now we just have this in terms of multiplication. All the times and divide are in the right place. So I do top times top, bottom times bottom. So do we need a common denominator for multiplication division? No, we don't. Okay, we only need it for addition and subtraction.